Okay, so we are looking at force, and we're going to be measuring force using a spring scale. Remember this device from earlier in the year? So so the first one, it's the first part of this says the diagram shows two trials of an experiment with a spring scale used to measure force. So we're measuring the force that either gravity or friction will have on a mass. So here it's on a flat surface, right? Well, I wish I could draw a flat surface right now, but I can't. So what we're going to be looking at is not a gravitational force, right? Because gravitational force would be up and down. Here we're going to be dragging it across a surface. So we're going to be measuring the friction force. Friction, and so the friction is going to be pulling this way, and this we're going to have a pulling force this way. So yeah. So we have one book in the first trial, and they're pulling it, and look at this difference here. So we don't know exactly what the numbers are. We can infer, we can say, well, maybe it's 1 or 2, judged by this spring scale. Maybe it's 1. We'll just call it 1. Why not? We'll say it's 1 Newton of force being used to pull this. So there we go. Now, if you look here, we added 2 books. The force of gravity is going to be pushing down on it more. Gravity is going to be pushing more. Therefore, we're going to have more friction as well. So more friction is going to be occurring because it's more weight pushing it down. And therefore, because the friction is going to be increased, we are going to have to increase the pulling force here. The pulling force is going to have to be increased in the opposite direction. So if you'll notice here, look, the pulling force has increased. We'll say that was the first one, twice, maybe 2.5 times. We'll say that's 2.5. 2.5 newtons. Okay? So now we're going to look at what they're really trying to ask us, what we're really trying to figure out. Okay, so how does blank affect the blank needed to move objects across the table? How does... Well, we've increased mass, which then in turn increased weight, which then increased friction. So the catalyst, the thing that changed it all, was mass. So we added mass. We also added volume, though. So that's interesting, huh? We'll just say mass. We'll say, how does mass affect the force needed to move objects across a table? But if you remember, when we added mass, we then added volume. Adding volume added a gravitational force. It added more force to be it's being pulled down more by gravity. When it's pulled down more by gravity, the friction force is going to be increased because you're going to have to drag it across a surface, and it's going to be pulling it more in the opposite direction. If that's pulling it more, frictions increase. Therefore, our pulling force has to increase as well. So now let's see, well, what's our variable? What are we changing? Are we changing the spring scale? No. Are we changing the mass of the object we're pulling? Yes. The mass has increased. This would probably be an actual invalid experiment because we not only increased mass, but we also increased our volume, right? And how could we make this a more, adequate a more adequate scientific investigation? Well, we could probably somehow, this would be a little difficult, but you would probably have to have some container, right? Some sort of container that had a mass in it to begin with, and then what we did, we just added more mass in that container. So it wouldn't change the volume, but instead just the mass increased. So here we're having mass and volume. So that's 2 variables, right? Oops, I can just spell volume. Volume. So 2 variables. Well, that's a problem, right? If we have 2 variables, that's an invalid experiment. Invalid experiment. Because there's 2 variables. So because 2 variables. Again, we could probably increase the reliability of this experiment by getting rid of the volume variable. By just having one case, we could make a big case. You could maybe get some sort of big box, right? And then put the book in it, have the same box, put 2 books in it. So the volume's not changing. Instead, it's just the mass. In reality, though, the only reason why the mass would make a difference is like maybe something like wind, friction from the wind or air pressure. So it really won't make too much of a difference in this experiment. However, if you wanted to be a stickler, be very precise, you would have to admit that you haven't included the volume change here. So there you go. So let's say, well, what is a valid conclusion if we were to say there was no volume variable? Well, if there wasn't, we could say, well, this conclusion would be the blank books included. So the more books included, the more force required to move the book, right? So that's the relationship. This is the relationship between the amount of books and the force used. So that would be a valid conclusion if we were somehow able to get rid of the volume variable. Okay, now the second part here says the diagram shows 4 trials. Okay, notice this. Every single one is using the same volume, the same mass, the same spring scale, the same distance between the spring scale and that mass. But the only difference is what? Yeah, the surface that we're pulling it on. Okay, so let's keep reading. Spring scale used to measure the force needed to move a 50-gram block across 4 different surfaces. So you've got carpet, table, rug, and a hall floor. So the hall floor, they're not really specific here. Let's just assume that they're talking about tile. Okay, so how do blank affect the blank needed to move a block? Well, also notice here, in each experiment, the amount of force is indeed different, right? So let's change it. How does friction affect the force needed to move a block? Well, we can tell that the carpet's going to have more surface area to be pushing on. Surface area means like there's more parts that's going to be touching, right? We're going to have carpet. Then the rug here, I'm guessing this is a short-haired rug, so that's going to have smaller surface area. The table is probably something like a wooden table, right? So it's going to be pretty flat. It won't be extremely flat. If you were to look with a microscope, of course, it would have those jagged edges, right? You would still see some jaggedness to it. And then the tile floor, very similar, but slightly less friction is going to be available because the force needed to pull it's going to be slightly less. So it's going to have a slightly less jagged if you were to look at it with a microscope or look on the molecular level there. But it is indeed still flat to our eyes, to our human eyes. So the tile floor is probably going to be the least amount of friction, therefore it's using the least amount of pulling force, which is exactly what we talked about here, right? The more mass you include to it, though, so think about it, if I put more mass here, well, it's going to take more force to move it because we're going to be increasing the gravitational pull on it, which then increases the friction. So this is very similar to what's going on here, except in this situation, we're on the same surface. Here, we're on different surfaces, and the mass hasn't changed, and the volume hasn't changed. All right, so what's our variable? Well, the surface. The surface that we are pulling this on each time. So this is a valid experiment because it's one that we can rely on. The only thing changing is indeed that surface. The volume of the brick isn't changing. The mass of the brick isn't changing. The distance of the string isn't changing. The spring scale isn't changing. Even the hand, it's still the left hand, right? That's left. Yeah, okay, good. All right, left hand isn't changing. It's all the same. So now we can say, yeah, without a shadow of doubt, this is a testable experiment. It's a valid experiment. It's reliable. So it's a valid conclusion. What's our valid conclusion? The blank required the most blank to move the block. Well, the carpet required the most force. The carpet, so notice here that difference here, right? The carpet is required the most force to move the block. That's because the carpet's going to have more friction, right? Because it's going to have more surface here. It's going to have more touching parts. And more touching parts, the more opportunity for it to, drag on it or pull on it. So there you go.